I will share the slides for this one, chapter 1. Okay, so boleh nampak? Okay.
Boleh, Doktor.
Alright, so I have uploaded your lecture notes in the e-learning. So if you have any problems, anything that you cannot understand, so please come back to me quickly. Right. So for this one, I mean the chapter 1, the introduction of electrochemistry and electrochemical concept. First of all, what can you, tell, or what you can give a definition of electrochemistry and how you can actually use electrochemistry in your, I don't know, maybe in your daily life. What are the application of electrochemistry that you use in your life? Anyone wanted to try? Now we can start with Hamda first. Hamda, are you there?
Hello, Doctor. Yeah.
Yeah. So what can you actually tell about electrochemistry, and what are the examples that you can see nearby you? I mean, that use electrochemistry application.
It deals with like in daily use. We can see like we use batteries.
It's a good example. Okay.
Yeah.
Very good example. And how about Mahdi?
Yes, doctor. We can see it in corrosion.
Okay. Well, corrosion is not really a daily life, but it's okay. I mean, I can still accept that. Mariam, do you have any idea? I mean, what are the examples of electrochemistry that you can see around you, or what is the definition of electrochemistry that you know?
I think in electrolytic, where we cut the spoon with the ring with gold or whatsoever.
Okay. Oh, good example. Nazira?
I'm thinking the same with Mariam.
No, okay. And how about Liana? You have any idea?
Also almost the same as Mariam actually. Electroplating.
Okay. All right. And Shamira? Shamira?
Yeah, I'm here, Doctor. It's battery, Doctor.
Battery. Okay.
Yep.
Right. Basically, electrochemistry is not something new for you guys, because electrochemistry, you have learned it during your high school. I mean, you learn about Voltaic cell. You also learn about, electrolytic cell and whatsoever. So you know what's the difference between electrolytic cell and also Voltaic cell or Daniel cell. Okay. Electrochemistry, looking at the name itself, you know, it is a combination between electrical and also chemistry. So this, I think, area is actually a concern with the interrelation of electrical and chemical effects. So you know, during your high school, you learn about electrolytic, and also you learn about voltaic cell. The energy change from chemical to electrical, from electrical to chemical. This is actually the things. Okay, so the chemical change caused by the pass of current. So when you, how the current is actually passing through, because you have the formation of electrons. So current is actually means that you have a movement of electrons. So movement of electron will create another effect that we call it as a current. Okay, and electrochemical system is not homogeneous, but it is heterogeneous. So why? it is not homogeneous because the process is dependent with one another. So as I said, electrochemical process is always related with redox reaction. So you have oxidation that occurs first. Oxidation means that metals or anything that produce electron, okay, and this electron will be donated, okay, to another terminal, okay. So the oxidation process always occurs at anode, and then the electron that produced will goes to the cathode, and the cathode will receive the electrons, and where the reduction process will be occurs there, okay. All right, so the application of electrochemistry that is applied, I think, in the daily life, of course, we talk about batteries. So battery, you can see used in your handphone, used in your many things in your devices and whatsoever. In fact, now you will see that the phone will be like as thin as like a piece of paper. I do remember during my study time, okay, the handphone is basically very thick, tebal, it's very heavy, it's very bulky, okay, and not like, I mean, recent technology. So all these are actually due to the advancement of science and technology, which makes electrochemistry more advanced. That is why I think like the current mobile phone you see it's very thin. Why? Because they use polymer electrolyte like Nafion and whatsoever that is actually made from polymer films. Those days, I think battery is made from nickel cadmium or probably lithium ion batteries. All these are very bulky batteries, very heavy and very dangerous because it can, I mean, after a certain use, it will be like oxidized and whatsoever. Then you will notice that the battery will become expand. So kalau siapa yang pakai bateri yang lama, I mean, if you guys use the old handphone, you might probably wonder why the battery is becoming expanding and then it can spin because it's already have trapped gas inside because it's already been oxidized. The broad application for electrochemistry, you can see it in the electrochemical analysis, electrophoresis, maybe those who are taking separation methods, you will learn about capillary electrophoresis, sensors, okay, because sensors is also using electrodes. You also have energy storage and conversion devices, corrosion, electrosynthesis, and also metal electroplating, right? Okay, so electroanalytical chemistry actually encompasses a group of quantitative analytical methods that are based upon the electrical properties of the analyte when it is made part of the electrochemical cell. So these methods makes possible for the determination of particular oxidation state of an element. So as I said, electrochemistry is always related with redox reaction. You have oxidation and also reduction. This process is considered reversible. Okay. And then there are two general types of electrochemical methods. One is actually known as potentiometric, where potentiometric means that there's no current, but it will be equilibrium potential, okay, or constant potential. And you also have voltammetric methods where current is measured as a function of applied potential. So for voltammetric methods, you will learn about cyclic voltammetry, scanning, or sweep methods, differential pulse, and whatsoever. Right. So when we talk about electrochemical process, we cannot run away with the cell. Cell is not like biological cell. I mean, this is actually the apparatus that is used to gather the electrode and also the electrolyte. So in electrochemistry, you have the terminality, anode and cathode. The anode is actually the electrode which the oxidation process occurs. Remember, anode is always related with oxidation. Meanwhile, cathode is the terminal where the reduction process occurs. Imagine that you have this equation, copper that is immersed in zinc ions or zinc salt solution. What happened is the copper will be oxidized and then zinc will be reduced. Okay, so there are two types of electrochemical cell that I think I have told you. You have a galvanic or voltaic cell, okay, that is spontaneously occurs, okay, to produce electrical energy, and you also have electrolytic cell that actually consume electrical energy and produce chemical energy. Okay, so anyone actually wanted to add on? I mean, or have some like things that you want to share about galvanic and electrolytic? Ada apa-apa ke? Anything that you want to share? Probably I can ask. What will be the examples of electrolytic cell for the production of what? Anyone knows? Siapa tahu? Mahdi? Do you have any idea? Not really. Not sure whether I'm talking alone or what. You guys can hear me?
Yes, yes, we can hear you.
Still thinking. Okay, right. So probably maybe you might guess, or I guess maybe you have learned this before, but let me just recap to you. Sekejap, why it is not functioning. Okay, all right, nice. So now, so we have electrolytic, and we also have a galvanic or voltaic cell. So what will be the difference between the two? Electrolytic actually, in terms of the energy conversion, this is where electrical energy is consumed, and it is actually producing chemical energy. Produce. Okay. Meanwhile, for galvanic cell, okay, galvanic cell actually chemical energy is consumed, and then electrical energy is produced. Okay, right. So the examples, I mean, electrolytic process, you can see, I mean, the electrolysis of water. Okay, so you have two similar electrodes. Okay. Right. So you have anode and also cathode. Okay. And forgot to tell you for electrolytic cell use two similar electrode. Okay. And of course, like similar and less reactive. For example, like carbon, okay, carbon, graphite, platinum, and whatsoever. Okay, all right. So over here, when you see the electrolysis of water, it produces two types of gas. Okay, so you can see one actually the anode will produce whatever gas. Anyone can guess over here what type of gas that it will produce. Siapa tahu? Anyone can guess? I think you've
CO2,
learned
Dr.
this. I mean, sorry?
CO2.
CO2. No, Mehdi, this is the electrolysis of water. Electrolysis of
Like
water
H2.
actually produce hydrogen
H2.
and O2.
Oxygen.
So this one you have anode and also cathode. So which one is actually cathode? Cathode is the short one. Cathode, and this is actually anode. Okay, for electrolytic. So what types of gas that is produced at cathode? Anyone knows? This is revision of high school electrochemistry. Anyone knows?
Hydrogen?
Hydrogen, kat mana?
Cathode.
Hydrogen at cathode. Okay. So Liana is guessing hydrogen at cathode and oxygen at anode. Is it correct? Answer is yes. Okay. Basically, you will have this will be positive and this will be negative. Okay. So the gas that will be produced at cathode is basically hydrogen gas. Okay. And then the gas that will be produced at anode is actually oxygen. And notice that the level over here, the type of gas, I mean the volume of gas produced over here and over here is not the same. Okay, so why hydrogen gas actually produce higher volumes? Anyone knows? 1 to 2. The ratio is actually 1 to 2. Okay, all right. Basically, when you have this process, okay, of water, you will notice that one terminality actually produce more gas. Okay, so if you see more gas is produced over here, you know that it is actually hydrogen produced. Okay, so what will be the process over here? I mean, so of course the process over here is 2H2O, okay, plus 2 electrons, and then you will have what? You have H2, okay, plus with 2OH minus, okay. Meanwhile over here, the reaction will be 2OH minus, okay, produce water, H2O, plus half oxygen plus electrons. You'll see that over here, half electron and 1 mole of hydrogen. So this is actually where the stoichiometry plays a role to determine the volume of gas produced. Okay. So again, as I said, for electrolytic cell, the difference in energy I think conversion is from electrical to chemical. Types of electrode is two similar electrodes. And then what are the things that you think you might know for electrolytic cell? Okay, so it uses external I think supply, which in this case it uses a battery. Okay, so examples will be electrolysis of water. And probably for galvanic cell, okay, so for this one, it will use two different electrodes with different activity. Okay, so how to determine the anode and cathode? Okay, so for this one, we have to refer to what? Anyone knows how we can determine anode or cathode for galvanic cell? We have to refer to what? Anyone knows what is ECS? ECS is actually stands for Electrochemical Series. Okay, so it will be like a list of table that lists the potential values. For example, you have copper, for example. Copper to copper 2 plus 2 electron. Okay, the standard potential E naught is maybe what? Positive 0.2. Okay, and then you have hydrogen. Okay, hydrogen 2H plus 2 electron. Okay, this one, I think the standard potential is equal to 0 volt, and then followed by maybe you have like I don't know, maybe iron Fe 2 plus 2 electrons, then standard potential is equals to minus 0.5, minus 0.5. And you can also have zinc 2 plus 2 electron, standard potential is equals to minus 0.7. Aluminium 3 plus 3 electron, standard potential is equals to minus 1.1 volt. So based on this series, okay, you will see that the potential values is becoming more negative. So of course, the more negative the standard potential is, the easier or the more reactive it's going to be. More reactive. So the more reactive elements will be anode. Okay, so it tends to form anode. So imagine that if you have probably Fe to aluminum pairing, so which one will be anode, which one will be cathode? Based on the definition. Aluminum will be?
Victor, depends on ECL.
Sorry?
It depends on ECL.
Depends on?
ECL, the potential of cell, the standard one.
Okay, yeah, we have to refer to the potential. So as I said, if you have a pairing between iron to aluminum, which one will be anode, which one will be cathode, based on the one that I explained just now? Anyone can guess?
Aluminium.
Yeah. Aluminium. Aluminium will be what?
Anode.
Anode. Siapa ni? Who is this? Mariam.
Mariam.
Okay. And Fe will be cathode. So this is actually true. As I said, the more negative the potential is, the easier it will become anode. Why it is easier to become anode? Because it is more reactive. Okay. So the more positive the potential, the standard potential, E naught, meaning that the less reactive it will be. Okay, and this one tends to be more cathodic. Okay, right? And before that, what does it mean by E naught? What is this? E naught. Can someone tell me what does it mean by E naught? Hamda?
Sorry, E cathode minus E cathode minus E anode.
Okay, that is actually how you can get the value. Okay, but E naught is actually a standard potential. Okay, so standard potential, what does it mean by standard potential? Standard potential means that you do the measurement, you do the electrochemical process at 1 atm pressure, okay, 1 molar of concentration, and okay, sorry, not this one, not 298. 298 is actually equals to 30 degree lah, 25 degrees C. Okay, 25 degrees C temperature. So if it fulfills this requirement, the pressure of the process is 1 atm, no pressure at all. You just use atmospheric pressure. Concentration of electrolyte is equals to 1 molarity, and temperature at 25 degrees C. So this actually considers as standard potential. Okay. That is why later on you will see the formula how you can get cell potential. But of course, for electrochemical cell, what will be the other components that makes it become conducting? Because you have metals. Metals will be the electrodes. Okay, and then you have the electrolytes. Okay, where the ions will be migrate, and also the reaction, of course, that occurs at the interface. So this is actually the examples of what is this is electrolytic or galvanic. This cell, is it electrolytic or galvanic? Based on what I have explained earlier.
Galvanic.
I think it's already mentioned here, galvanic or percantor. Yeah, but actually how you can determine it is a galvanic, because you can see, okay, the two electrodes is not the same. It use zinc at one side, and then you have copper at the other side, and the electrolyte used is being separated. Okay, so this is also another features of galvanic cell, because for copper, okay, it is immersed in copper salt solution. Okay, meanwhile for zinc, it is immersed in zinc salt solution. So to make this cell become complete, we need a salt bridge. Anyone knows what's the function of salt bridge?
For the transfer of electrons.
Yeah, I mean for the transfer of electron or to complete the cell, because you can see electron is actually moving. Zinc is over here. Zinc will become anode. Okay, because zinc is more reactive as compared to copper. As I said, copper, the cell potential is equals to positive 0.2 volts. Zinc is equals to minus 0.7, for example, volt. Okay, so this is more negative, this is more reactive, and it becomes anode. So over here, you can see the reaction zinc will become zinc 2 plus 2 electrons. Remember, for anode, it is always an oxidation process, okay, where electron is produced. So once electron is produced, first it will transfer to the wires, okay, goes into voltmeter. Voltmeter will measure the potential produced, goes into the copper electrodes, and copper electrode will receive the electron and it will be reduced. So reduce, it become copper solid, and then to complete the reaction, as I said, the electron movement again occurs over here. Okay, so a potential difference between the two electrodes represent the tendency of the reaction to occur. So the cell potential, E cell, okay, this is where or this is how you can calculate the overall potential process, okay, or the overall potential values. Is it clear?
Yes, doctor.
Right. So this formula, I guess maybe you have learned maybe in your high school, and remember this must be standard. There's a reason for that, okay? And later on, maybe we will explain. What about the process that occurs not in the standard condition? Okay, so electrochemical cells and reaction. So as I said, components that needed in the electrochemical cell, of course, you need an electrode, you need electrolyte, you need also conduction, right? So when all these things actually equipped in your electrochemical cell, then the process occurs and resulted a phenomenon so-called interface. Okay, so interface is actually a process where phase is separated. Okay, interface. Okay, interface process or phenomenon where phases are separated. Okay, so for metals, you know, electrodes. Electrodes, what will be the phase? The phase will always going to be solid. Metal, the phase will be solid, and then between electrodes and electrolyte, you have a different or a boundary. Okay, so we put a slash. Slash means that to separate the different phases. So you have electrolyte. Okay, the phase will be in liquid or aqueous. Anyone knows? Electrolyte. Is it in liquid or in aqueous?
Aqueous.
Why aqueous? Sebab apa? Mariam jawab tadi.
Bukan.
Bukan.
Nazira.
Oh. Syamira?
Nazira.
Oh, Nazira. Okay. Saya baru nak kenal suara. Okay. Alright. So the reason why it is in aqueous, because remember, electrolyte, okay, this is also another concept of electrochemistry. What will be the requirement for electrolyte? Okay, so first, you know that it must be conducting, okay, and if it is not conducting, for example, maybe you have salt, okay, if you use salt alone, okay, it's not going to conduct electricity, okay, because it is in solid phase. But if you melt it, molten salt, then what will happen is salt will be dissociated into ions. Okay, so when you have ions, free ions, it will conduct electricity because ions actually have produce electrons and whatsoever. Then this is actually what making the material become more conductive. So why it become aqueous? Aqueous actually means that you have water plus with salt. Okay, water is conducting. Okay, but in electrolytic cell or galvanic cell, okay, especially galvanic cell, you know that the metals that you use as an anode or cathode, it cannot be immersed similarly. Okay, meaning that if you use copper and zinc, you cannot immerse it in copper salt solution only. It must be separated. It must be have its own electrolyte. So that is why you should use salt, okay, and then dissolve it in water to make it more conductive. So this is actually the requirement. So electrolyte, it must be either molten salt, okay, or aqueous solution, right? Right, so back to this one interface, you have metal as a solid and also electrolyte as in aqueous phase. Okay, you also have a tendency of solid to solid interface, liquid or aqueous to aqueous interface, and for a more complicated cell design, you have like a lower concentration, okay, with a semi-permeable membrane with a higher concentration of solution. All right. So in this topic, we are going to concern more on the interface between electronic conductor, which in this case, I think we are going to address more on metals to electrolyte interface. So in electrode, charge is transported by electron movement, and in electrolyte, charge is carried by ion movement. So this you need to understand. So in electrode, okay, the charge is actually transported or carried by electron movement. Meanwhile, in electrolyte, the charge is actually carried by the ions movement. Okay, so electrochemical cell, you have like two electrodes separated with at least one electrolyte phase. So it can be two electrolyte phase if it is in a galvanic cell. So the difference of electric potential measured between the two electrodes and the cell potential in volt are a measure of energy available to drive the charge externally between the electrodes, where 1 volt is actually equals to 1 joule over coulombs. Okay. So notation, cell notation, this is also important for you guys. Maybe it's just a recap of what you have learned before this. So you know that in those days, you have this notation. It is actually used to to tell you what would be the anode, what would be the cathode, and what would be the process and products that it produces. Slash actually represents the phase boundary. Comma actually separates the two components in the same phase. Okay. And double slash represent the phase boundary whose potential is regarded as negligible. Okay. So when gas is involved, remember, when you see gas is produced, like for example, hydrogen, okay, so you must know that, okay, the electrode that is used to produce gas must be, non-reactive electrodes or metals, which in this case, platinum. Platinum, okay, is non-reactive. It can be cathodic. In this reaction, it will be cathodic because in this notation, what you can see, platinum slash hydrogen, okay, slash H plus and Cl minus. What is actually mean over here is that you have HCl, okay, acid as the electrolyte, and then you have platinum as one electrode. And then this one you have silver, right? So which one will be anode? Of course, this one will be anode, and this one will be cathode. So why platinum will be cathode? Because platinum is actually non-reactive, and then it produces hydrogen gas. So anything that produces hydrogen gas, this is actually reduction process. Reduction process. Okay. So Ag become Ag plus electron. So this is oxidation. All right. The overall chemical reaction is made up of the two independent half reaction, the real chemical changes at two electrodes. So each half reaction and consequently the chemical composition of the system near the electrode responds to the interfacial potential between difference at the corresponding electrodes. Right. And for electrodes, okay, so for types of electrodes in electrochemical process, you have many things. I think, let me just tell you, for electrodes, you have WE, you also have CE, and you have RE. Remember all these three. So WE is actually working electrode. CE is counter electrode. And RE is actually reference electrode. Okay. So working electrode, what does it mean by working electrodes? Working electrode is electrode of interest. Okay, so for example, if you use metals as electrode, so you know that you are going to study the oxidation of this metal. So this is actually your interest. It will be working electrodes, right? Counter electrodes, meanwhile, okay, is a type of electrode that is used to measure what? Anyone knows? Counter electrode. It is used to measure what? Siapa tahu? Nazira. Kita tanya Nazira. Nazira banyak jawab tadi. Nazira tahu?
Tak ingat dah.
Okay.
Satu lagi lah.
Counter electrode
Potential.
is used to measure current. Remember, anything that you want to measure current, it is not from working electrode or not from reference electrode, but it is actually measured by counter electrodes. Okay, so counter electrode, sometimes they call it also as auxiliary electrode. Auxiliary electrodes. Okay, electrode bergerak, auxiliary electrodes. So used to measure current. Okay, and for counter electrode, it must be non-reactive electrodes or metals. It must be non-reactive, because otherwise, if, for example, working electrode, because working electrode is the electrode of interest, this actually produce potential. Okay, it produce potential. Okay. If your counter electrode is also active, then you have two electrodes that actually active, producing potential, and later on maybe your your electrochemical system will be pening. I mean, like in chaos, because you have two active material at the same time. Maybe it will actually consider which one is more reactive. Then that one would be a working electrode, I mean, of interest, or anode. All right. So what would be the example of non-reactive electrode used in counter or auxiliary electrode? So examples, you can use carbon, graphite, carbon or graphite, platinum. Okay, these few examples that people use commonly, okay, as a counter electrode. And lastly, you have a reference electrode. So reference electrode, what is the function? Nazira ingat juga? Tak ingat?
Dia use as a reference untuk measure potential kan? Betul tak? Dia use as a reference.
Yes. Actually, okay, reference electrode is used to measure potential. Because you know, working electrodes, as I said, metals, it produce potential. So when it produces potential, it needs something to measure it. Then that is why I think reference electrode plays their role. Okay, it used to measure potential, and as what Nazira was telling, okay, it is also used as a reference. Okay, so that is why over here you'll see that for reference electrode you have different types of electrode. You have standard hydrogen electrode, SHE. You also have normal hydrogen electrode NHE, or sometimes I think this one is the most common use lah, silver chloride, AgCl, and saturated calomel electrodes. Okay, right. So these a few examples of reference electrode use. Why people use standard hydrogen electrodes? Because hydrogen, okay, the potential is actually equals to 0. Okay, standard potential of hydrogen is equal to 0 volt. So this can be used as an indicator, because at the end, if you want to calculate E cell, remember, okay, you must calculate, like cathode minus with anode or whatsoever, then you see the difference. So when you see the difference, then you can, if it is, subtracted with 0, then you will have a value. If it is subtracted with another value, then it will be more tricky. Okay, all right. But the disadvantage of standard hydrogen electrode is because when you use hydrogen electrodes, okay, then hydrogen is produced. Then this electrode or this hydrogen gas is considered explosive lah. You learn in your high school that if you have anything exposed to hydrogen, if you have a glowing splinter, what happened? It produces what? What sound? Pop sound. Okay, but if the amount of hydrogen gas is bigger, then it's no longer pop sound lah. Boom terus. Okay, right. So because, as I said, the disadvantages of standard hydrogen electrodes, because it's producing much hydrogen gas and maybe it's a bit dangerous to use, people tends to find alternative. That is why they use silver chloride or saturated calomel electrodes. Okay, so for silver chloride, what will be the anatomy of these electrodes? To produce silver chloride electrode is very simple. Even you can produce by yourself. I remember during my PhD time, I produced my own silver chloride electrode. It's very easy. You have a wire, and then you just solder it to a silver wire. Okay, you solder it, and then you put in the capillary. Normally, I think those days I use dropper, because dropper, it has a very unique shape, like this. Okay, so I just break off the end, and then I put some porous material. Sometimes I put like silica powder, or maybe I put some other things that is porous over here. And then I just fill in potassium chloride solution also, inside. Okay, then this is already reference electrode. Okay, very cheap. If you buy it outside, maybe it can cost you like around 500 ringgit or something like that. Okay, but if you produce like this, I think maybe the cost is very, very cheap. Okay, all right. So this is actually the anatomy of silver chloride. It uses silver wire, silver wire. Okay, and then you also have saturated calomel. Okay, saturated calomel is a bit, I think, complicated, because you have mercurous chloride, Hg2Cl2. Okay. Right. Okay. So you have mercurous chloride. Okay. And then this time, still the same thing. I think inside the electrode, you put KCl solution, saturated. It must be, saturated, or the concentration is quite high. Okay. So what are the difference between silver chloride and also SCE, saturated calomel? The difference is the amount of potential produced. The amount of potential produced for saturated calomel is 0.242 volt. Meanwhile, for silver chloride, the amount of potential produced is 0.197. Basically, the difference is not that much. I mean, like one is actually 0.24, another one is 0.19. Okay, so because the difference is not too much, but I think in terms of the accuracy of giving potential value, SCE is more favored because over here, the types of metals that is used to trap the ions or the electrons is mercurous chloride. So mercury, it is like amalgam. I mean, a semi-liquid, semi-solid. So the diameter or the dimension over here is more spherical. It's more like bulat lah. I mean, like spherical. Meanwhile, for silver, if you see the dimension over here is more cylindrical. So if you have like ions, ions, positive, negative, that goes okay over here, it is a bit, not to say difficult, but for mercury it's more feasible because the ions can attack them at any sides, okay, because the shape is round. Meanwhile, for this one, maybe it needs some orientation, I mean, to be reacted. Okay, so that is why the price of saturated calomel electrode is slightly expensive. Maybe like a simple setup, the price can range to 2,000, sorry, 2,000, 2,000, okay, to 3,000, okay, ringgit. Meanwhile, for this one, as I said, very cheap. Maybe you can get less than 500 ringgit or around 500 ringgit. Okay, so the purpose, as I said, electrodes. Okay, you have like working electrodes as electrodes of interest. Counter electrode is used to measure current, and reference electrode is used to measure potential. Is there anything that you want to ask so far? Ada apa-apa soalan? Anything? Anything that you want to ask? Nazira?
Doctor.
Yeah.
Okay, Doctor. I would like to ask, what's the difference between SHE, standard hydrogen electrode, and normal hydrogen electrode?
Okay, all right. So what's the difference between standard hydrogen electrodes and normal hydrogen electrode? Okay, the difference is basically based on the dimension. As I said, I don't have the picture of standard hydrogen electrodes over here, but maybe later on you can Google the image. Standard hydrogen electrodes, actually you need, there is a hydrogen inlet, hydrogen inlet that goes into the electrode. Meanwhile, for a normal hydrogen electrode, is not as complicated as standard hydrogen electrodes. So it's more like compact, more feasible, no hydrogen inlets, and I think easy to apply. But the thing is, for standard hydrogen electrode, it is more accurate, slightly accurate as compared to normal hydrogen electrodes. The reason why, because when you have hydrogen gas that is been inserted in the electrodes continuously, then the measurement will be more accurate because the reduction process will occur continuously. Not, I mean, like normal hydrogen electrode where the hydrogen gas is trapped there. They are not continuous. Okay, so during the measurement or whatsoever, maybe if there's a leakage or whatsoever, then yeah, maybe it is becoming tedious for people who run the experiment. Okay, anything, any other things yet that you want to ask apart from that? Okay, clear. Siapa ni, Liana?
Okay, clear. Thank you.
Okay. Any other question before we move on? Maybe we just move on slightly a bit before we call for the day. And maybe for the introductory part, I don't want to confuse you guys. I just want you guys to relax and digest it slowly. Okay. Right. We're moving on to the electrode process. So as I said, the types of electrode that we always use in this communication or in this discussion is basically on metals. Okay. So of course, how does the electrons is produced and whatsoever? It is actually due to a process. We talk about oxidation, we talk about reduction and whatsoever. This is basically the types of process that explain how the electron is being donated or maybe transferred. Okay. So any changes in the cell are ascribable to the working electrodes. So by driving the electrode to more negative potential, okay, so the energy of electrons will be raised, and energy reach a level high enough to transfer into vacant electronic states where there is a flow of electrons from electrode to solution. So this process is known as a reduction current. Okay. Similarly, the energy that can be lowered by imposing a more positive potential, and at some point, electrons on solute in the electrolyte will find a more favorable energy on the electrode and will be transferred there. So their flow from solution to electrode is known as oxidation current. The critical potential at which these processes occurs are related to the standard potentials for specific chemical substances in the system. All right. Maybe if you read this, it sounds a bit, chaos to you. Maybe it's a bit difficult for you to understand, but actually the explanation is very simple as what we have explained earlier. Okay, so imagine that you have a cell with electrodes, metals, for example, connected to each other, and then you have electrolyte. Okay, let's say we are talking about galvanic cell. You have over here aluminium, and you have over here iron. Okay, so first of all, before the process occurs, you know that galvanic process, it occurs simultaneously or spontaneous. Okay. Right. So how it becomes spontaneous? Because first, when you connect these two things together, immediately the electrode will, place it rose and making like aluminium become anode, and then iron will become cathode. I think the reason I've explained earlier that this is actually based on the standard potential value from electrochemical series. Aluminium is more negative as compared to iron. Then this is more favorable to become anode. Right. So then how the electron is produced? Okay. So as you know, for anode, of course, it is always related with oxidation process. Then aluminium, okay, will become aluminium 3 plus 3 electrons. So this is actually the half equation that you see. But what about the explanation in terms of molecular orbitals? This is where you see over here. Okay, so maybe I also didn't memorize what would be the electronic configuration of aluminium, 1s2, 2s2, whatsoever. But you know that in their d orbital, okay, what will happen is 3 electrons, okay, will be promoted, okay, will be promoted into the higher band, meaning that in the occupied molecular orbitals, okay, this is where all the electrons have been like located, and then you have a vacant molecular orbital. So what happened is when there is a change of energy, okay, over here, if you read carefully, you increase or decrease the energy level, then you have the promotion of electrons or maybe a reduction or the downgrades of electrons. So from occupied molecular orbital into the vacant molecular orbital. So in this case, like for example, for aluminum, okay, you see at their valence electron at the occupied molecular orbitals. Okay, so it will be equipped with maybe extra one electrons, and then you have like another one. Okay, so this one tends to I think promoted into the vacant molecular orbital because it is not paired. Okay, not pairing. Okay, so it is least stable. Okay, then it will be promoted easily. And for the other two electrons is also the same thing because it is located, if you understand the valence band theory, if you have like, for example, maybe 3 unoccupied electrons, then what will happen is it's tend to easily donated or lose its electron. So this 3 electrons can be easily lost and it goes to the vacant molecular orbital. So this process is known as, it's known as reduction current. And then what about the process that occurs at the cathode? Okay, this is actually where the reduction process occur. So when the reduction process occur over here, it actually receive electron and becoming reduced. Okay? So maybe the half equation over here is Fe2 plus 2 electrons, it will become Fe. Right? So it receive or accept electrons. So electrons form the one that is produced from aluminum. But over here you will see that it is not balanced. So probably later on you will like to manage the stoichiometry, you will multiply it with factor of 3, factor of 2, for examples. Okay, if you multiply with factor of 2, you have like 2, 6, then you have like 3, 6, 3. Okay, then the electron is balanced. Okay, at the end. Okay, so then the process is actually known as oxidation current. So remember, reduction current and oxidation current is not meaning that reduction current must be for reduction process. No, reduction current, it means that the electrons that is produced later it will be used for reduction. So that is why oxidation process, it produces electron, and this electron will be used later on for reduction. So that is why we call it as reduction current. Meanwhile, for oxidation current, it means that the electrons that it receives actually from oxidation process to actually produce a reduction. Okay, so I hope you are not confused with the terms. Maybe you think that, oh, reduction current is actually for cathode, for reduction process. No, it's actually for oxidation process at anode. Right? Is it clear? Is it okay for you guys? Okay, girl?
Okay.
Okay.
All right. So standard potential is the same thing. I think standard potential is the overall cell potential because you have a potential that is produced at aluminum and another potential that is produced at cathode. So altogether, if you calculate the E cell, E naught cell, you will see the difference between E cell cathode minus with E naught anode. Then you will get the overall cell potential. Okay. Maybe one or two slides before we end. I guess maybe I will stop it here because next is actually a special things that we will explain on Thursday. All right. Fast and slow electro process. How to determine process that is fast or a slow process? Fast process normally occurs if, like for example, you have a very active electrode, which in this case, if you have metals that is having a more negative standard potential. So the types of process will be faster because it's more spontaneous, it's more reactive, and it can occur simultaneously. Meanwhile, slow electrode process is where the electrode used during the electrochemical process is less reactive, like a more positive standard potential. So this actually will produce a more slower process. I mean, in a nutshell. Maybe if you read this, you will think like twice or what, because it's more abstract over here. The write out is more abstract. But as I said, for fast and slow electrode, okay, you will have a fast electrode process if the electrode used is actually a more reactive process. Fast electrode process is where you have a more reactive metals or electrodes, which in this case may be a more negative anode, okay, and for slow electrode process, this is where you have a less reactive metal. Oh man, my handwriting is macam apa, I'm not sure whether you guys can read it or not. I'm very sorry for my Roman punya ni lah writing. Okay, so this is for more positive standard potential. Okay, then you have a slow electrode process. Right. So as a comparison, okay, you will see that if, for example, you have this one is actually to differentiate between I think a fast and slow electrodes process, where as the potential is applied more negative than equilibrium potential, then a net current will flow. Then you will see the difference is a more linear. Meanwhile, if a potential is applied more positive at anodizing or more anodic than equilibrium potential, a net of current flow in opposite direction. Okay, so this case is actually to mention that this actually will experience oxidation, and this actually will experience reduction. Okay, so if you notice over here, if it is a fast process, okay, so fast process means that it is an active electrodes, it becomes oxidation, and then the response will be more positive, okay, and then you will see that the type of response that you will get from current to potential behavior is exponential. Exponential increase. Okay, exponential increase means that the process is very fast. It's not like a gradient. I mean, like it's not going like slowly build up. It's very fast, like suddenly like a rocket, zoom. Okay, going up. Okay, so this actually indicates fast electrode process. Meanwhile, for over here, you see that it is build up gradually. Then this actually known as slow electrode process. Okay, and mostly for reduction process. I mean or less reactive electrode that will experience slow electrode process. So in a nutshell, for electrochemical process, it is a combination between fast and slow process, where fast process occurs at anode and slow electrode process occurs at cathode. Okay, all right, is it clear? Clear? All right, so is there any question, I mean, regarding on fast and slow electrodes? Anything that you want to ask? Or before that, anything that you want to ask?
Doktor,
Yeah.
saya a bit confused ya.
Yeah.
Tadi, okay, the left one, this one is slow electrode process. So this is the reduction.
Yeah.
So this is more positive standard potential, right?
Which one? I mean the right one.
The left one.
Doctor, before this slide you mentioned that the more reactive is fast, but here you said anodic is so fast. It's fast than, yeah.
This one, you mean?
Yeah, in this slide. You say here you wrote.
This one?
No. Yeah, this one. Fast electrodes, more reactive. That means cathodes.
More reactive cathode? No. You see over there, I put in a bracket negative potential, right? Is this what you mean?
Yeah,
yes,
more. Yeah.
Negative
Okay.
potential.
Right. So this is actually not represent on this response. Okay, Chini. Right. What I'm going to tell over here is that for the fast process, how do we indicate that this is occurs at anode? It is actually basically looking at standard potential in the electrochemical series. Okay. Another example, I give you the same example lah. Okay, you have aluminium again and iron. Okay, so first, how do we indicate that it is anode or cathode? Of course, as I said, this one, the cell potential is equals to minus 1.1 volt, and this one, cell potential or the standard potential is equals to minus 0.5 volt or 0.4, right? So basically what I mean is which one will become a fast electrode process is first you look at metals that has more negative potential, standard potential value. Okay, so over here, this is more negative as compared to this one, correct? Okay, so this will be anode, and because of it is more negative, then it is more reactive, okay, process. So what will happen is that when you see over here, okay, this is not actually the response of the standard potential, but this is actually during the measurement, during the measurement of I mean electrochemical series. Maybe if you use a voltmeter or something like that, I mean as a response between current to potential values, you will see that the trend, okay, from negative to positive, okay, is going to be like exponential, okay, negative to positive, because and it is not like a negative exponential is become like positive. This is a positive exponential. So meaning that as you increase the potential from maybe, okay, from minus 1.1 up to maybe minus 0.5, for example, because we are comparing between the two electrodes. Okay, from minus 1.1 to minus 0.5, this is actually going more positive, right? Betul tak? Okay, so you will see that the response of current, it will be increased exponentially. Meanwhile, for this one, okay, the measurement, you will see that it's not actually forming exponential, is actually forming linearly. So this is actually the measurement if you look from minus 0.5, more negative is going to more negative to 1.1 volt. Is it okay? Masih confused? Siapa yang tanya tadi?
Okay.
Diana?
Yes. I think we got you. The thing is, I thought that the if a potential, I thought this is the standard potential.
Oh no, this is actually
Okay.
the measured potential. It's not the standard potential, because at the end, if we want to calculate E cell, okay, we have to do the scan from one potential to another potential. So it is actually from minus 1.1 to minus 0.5. So this is actually where the measurement is. Then you will see the current response. So you will see that over here, it is not actually going to linear, is actually forming a shape of exponential. Then this actually indicating that, okay, during this measurement, it is a fast process because aluminium actively producing electrons. Producing electrons actively. Kalau kita letak, if you put aluminium in the solution, you will see that it will be dissolved fast and whatsoever. Okay, all right.
Doctor.
Yeah.
Yeah, the more negative is anode or cathode?
The more negative is anode or cathode?
Yeah.
Yeah, the more negative is anode.
Is anode, but previously you said it's cathode when you mentioned in the
I think maybe you still cannot get it, buddy. What I mean is,
it.
Sorry?
Because I'm confused now because in the first or second slides.
Is it this one?
No, the previous one. I think it's 3-4 slides.
Which one?
Which one? Yeah, this one.
This one?
No, before this.
This one?
Yeah, this one.
Okay.
Yeah, you said here Fe with Al.
Yeah, this is Electrochemical Series, ECS.
Yeah.
You will see over here, okay? Did you notice this standard potential? The standard potential value? Aluminium minus 1.1, zinc minus 0.7, okay?
Oh, okay. Now I get it. That means.
So you see, aluminium over here is more negative as compared to the rest.
Yeah, anode. Yeah, you are right.
So when you see that it's more negative, then it will be more reactive. Then it will be easier to become anode.
Okay, doctor.
Okay, ready?
Okay, yeah, I got it.
Okay, all right. Okay, so all right. Of course, if you go back, later on, if you read out and you think that you're still confused or whatsoever, you can come back to me again, and then maybe we can discuss again. But I think theoretically, to conclude what we have learned today is more or less on determining anode and cathode, and how anode and cathode influence the electrochemical process, fast, slow, and then what will be the process, in terms of how the electron is produced because of what. But I think more or less it's just cascaded like that. It's just, going to the same circle. The more reactive electrode, because of the standard potential value is more negative, then it tends to experience oxidation rather than reduction. Then all this actually in complement with the other things. We also have learned about this 3 types of electrodes that maybe later on you can differentiate what does it mean by working electrode, what does it mean by counter and reference electrode. Okay, and I think maybe on Thursday we are going to address this. Right, so you've also heard about this during your high school, or probably during your undergraduate, Nernst equation. So Nernst equation is basically used to calculate cell potential, E cell, which is not at standard condition, non-standard condition. Okay, so remember back again what I have told you earlier, that what does it mean by standard condition? It's just to revise. What does it mean by standard condition, Madi?
The standard that is unknown for the metals or for the electrodes, cathode are unknown that we give.
Okay. The rest we will like to try. Shamira? Syamira, dengar suara Syamira pula.
It's the temperature is 25 degrees Celsius, pressure 180 atm, and the concentration is 1 mole.
Exactly. So if it is not following this, for example, temperature is not 25, pressure is not 1 atm, or concentration is not 1 molar, then how to calculate the cell potential or the overall potential, we have to use this Nernst equation. So Nernst equation is actually a consideration of a standard potential plus with the other effect, especially on the activity or the concentration of reactant and also concentration of product. So this, I think we will continue on Thursday lah. So so far, is there anything that you want to ask? Anything? Any other things? Oh, forgot to tell you, maybe you can fill in the attendance. I think attendance is available in e-learning. So you just like click that you.
Doctor, is there a password?
No, sorry?
Is there a password to attend this?
No password. I think you just access to e-learning and then go to attendance and then you just check.
Okay,
I mean,
no,
on the day that.
Doctor, I think my e-learning still not update yet, so I still cannot see the discourse.
Oh, really? Oh,
Yeah.
okay. I see. Siapa tu? Nazira ke?
Shamira.
Syamira. Okay.
Yeah.
Doctor, attendance is not shown still. We can't
really?
click anything. Yeah.
Even my lecture note is also not appear there.
No, it's seen, but attendance cannot click anything. Cannot click in the attendance part.
I also cannot see the attendance.
Attendance is not there. Oh,
Yeah.
okay. Okay. Oh, never mind. I think later on I will check because these few days, if you notice, there's a problem with I think registration system and whatsoever. It seems that students cannot register or whatsoever. I mean, the exam unit are trying to like solve this problem, but never mind. I think I've maybe at the moment we just wait until the system is okay, and maybe later in the afternoon you can try again. I will try to contact Mr. Akimi to solve this thing. But lecture notes and everything you can access, right?
Yes.
Okay.
Yes.
Okay. All right. Okay. All right. So I think I would like to call for the day. It's been long, I guess. Maybe you guys also a bit tired. Okay. So again, I mean, if you guys have a problem, I mean, later on when you revise back the notes and whatsoever, we can like discuss it again on Thursday. Okay. So maybe last one, I just want to ask: is there anything that you want to add on? Any question? Anything that you cannot understand, cannot follow? Okay. 1, 2, 3. Then I guess it's all okay. And thank you very much for your time, and hopefully to see you again on Thursday at the same channel, WebEx. With that, thank you very much, and Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Have a nice day.
Doctor.
Yeah,
Thank you,
welcome.